In this lecture, we're going to talk about the unit vector. Firstly, we will discuss it separately. What is unit and the vector? Unit means one or unity. Unit, where the term unit is used, we just consider that position or that condition one. Vector is any quantity which consists of direction, particular, that is particular, and also a magnitude. So here it is written, vector quantities have magnitude, direction and units. Now what are the vector? Vector represented as A, an arrow on the top, that's the identification of the vector. Magnitude is written in the mods, magnitude and direction. Now here's a term or here's something new used. Now we will just discuss what it is. Unit vector is a vector which has magnitude 1. As I talk, unit is the 1. Unit is considered as the 1. So any quantity or any vector which has magnitude 1 or unit is written by placing cap on it, or it is the symbol of the unit vector that is used to just denote the unity of the vector or quantity. Unit vector does not shows the actual direction, only it shows the direction. Unit vector just shows, like, just suppose now this is a scale. Unit vector, it just shows the direction of the thing. Like we are just talking, this is a pen, it is placed there. Now I am not showing the actual distance or displacement or whatever, I am just showing the direction, it is there. So that is called the unit vector. And written is the cap is written to just shows the unity, and it does not affect the quantity or the magnitude much. Like it just is used to shows the unity of the direction. Like we have just identification that this is a vector quantity, it has had direction. So for that we use the unit cap. Now here are some examples. E is equal to F upon Q. This is electric. Now E is equal to F upon Q and unit vector R is just multiplied by this whole equation. Nothing happened. R is equal to 1. So 1 is multiplied by whole. So nothing will change. It will just give the direction of the vector to it. Now that's all about its definition. Now there are some unit vectors or unit direction that used in scales or in any other thing very commonly. So we're gonna just talk about that. Now we know that there are three axes, x-axis, y-axis and z-axis. Now to show the direction, x-axis is denoted by I by placing cap on it, y-axis denoted by j and z-axis denoted by k. These axes are perpendicular to each other at 90 degree. As it is shown, this is 90, this is 90 and this is also 90. So these all are 90 and these type of perpendicular are called mutual perpendicular. Mutual means in physics, in the unit vector, mutual means 90 degree. These all are 90 degree perpendicular. So we just call it the mutual perpendiculars. Now the example of this axis is the room, which has the four corners. It's a rectangle or rather a square. Now we're gonna just see that, just suppose leave the room. Just suppose this is a cube. Now these are the axes. Z-axis. Now it does not have, we can just say it's the y-axis, z-axis and x-axis. Now this is called perpendicular, mutual perpendiculars. Now how to make a diagram or show the direction in it. Suppose a thing or a object that moves in the x and y axis. Now this is denoted by the AYJ. Okay. Now the distance covered, just suppose this is the force and this is the distance. Now the distance covered is equal to this, but on the y-axis it just moves like that, and here it is also shown the distance covered is this. It will just show the thing like that, and to calculate these type of equations we just use the formula that is called this. If we have three axes, we will just write ax square vector ax square ay square az square by whole squaring. The radical or under root will be cancelled, and it will just become ax ay az, and that's all about its calculation. Now let's talk about the free vector. We can see the word free means with no boundings. It does not have any boundings. As the word says free, it has the same direction or same definition. It is a vector that is displaced parallel to itself and do not lie on the origin. It does not lie on the origin, shows the freeness or no bounding of that object or vector. And it moves parallel, that is the identification of the free vector. Now just suppose it at the scale, an object that starts from 1 and it goes like that. Then it just moves above and it get started from the 3.1 to this. It is just parallel to it, and this is called the free vector. In the position vector, it's just opposite the free vector. It has an origin, it starts from origin, but it also shows the direction of the object. Like just suppose this is O, this is P. Now it will show the direction of the O and the P. That is called the position vector. It shows the position. The word position means the point or the place of that object. So that's all about today's lecture.